To rephrase what I'm going to say later, but you haven't heard yet because the video is just starting, the already high odds of me saying something stupid on this channel, well, are about to skyrocket.
Welcome back to WTOT 1000s FM. We can't stop talking about how much we don't talk.
Well now, frankly, I wasn't expecting the amount of interest and questions that came out of that last video. It would appear that a quick follow-up is in order. And my apologies. I should have opened the welder up for you. The failing health of my TIG was more of an excuse to talk waveforms, but having a look inside sounds reasonable. Let's chalk that up to a momentary lapse in good judgment, shall we? That, and it gives me a chance to explain why I probably won't try to fix this right now. I mean, just have a look at this. It looks like they built a normal welder and put it through a trash compactor. I'm surprised air can even get through it. Now, I'm no electronics whiz, but honestly, I'd have no qualms trying to dig through this with a scope and schematics. The problem is, it'd likely take me a month to find the issue, if I'd even find it, really. I'm sure someone with more experience might go through this in a couple of days. Unfortunately, that's just not the case for me. And truth be told, I have a laundry list of reasons I'd prefer to upgrade rather than dig into this thing right now. And faced with that apparent time investment, I'm going to opt for the easy way out. Now, although the crazy waveforms and erratic behavior we saw in the last video effectively mean less heat out of an already small machine, fact of the matter is it still welds. It's still a better welder than I am by a mile. So the plan was to keep using this one until I found a replacement. Then I could play with trying to fix this all I wanted or hand it off to someone smarter than me. All of that would be fine and good if it weren't for a few comments that suggested further use might do more harm than good. I hadn't even considered that. So let's try some low-hanging fruit while I further consider my situation. We'll have a closer look inside, clean it up a little, check some connections, stuff like that. I hadn't even thought to harness the power of the hive mind. Certainly let me know if you see anything funny or have any ideas once we sort of just walk through this. That's a tall order, I appreciate that, but maybe I get lucky. I know I probably shouldn't be using shop compressor air, but that's all I got. Relatively dry and clean, and I've got the pressure real low. You know what, I think I hear something rattling around in there. I wonder if I can... Listen, you grab that wrench and you're heading back in there. I don't want to see it till it's fixed. This time, stay away from the black hole chip. You got it? Knew we should have gotten a dog. So if it weren't for how tight it's packed, the welder frankly doesn't look that bad. It's a lot of big, through-hole, new old stock components from the 70s. But I mean, just take a look at these wrought iron cables. Just trying to get those out of the way would take like a 3-foot cheater bar. The only really daunting looking part of this thing is that little control board on the bottom there. I'll try to get a closer shot. It's all surface mount, I don't know, logic kind of stuff maybe. Before I take you on the nickel tour of the insides, allow me to address a few comments from the previous video in no particular order. Some viewers took offense to my pronunciation of oscilloscope, to which I offer the following. Oscillate, oscillator, oscilloscope. Settle down now, settle down. I can hear you from here. I looked up the pronunciation and you are correct. I'm pronouncing it wrong. To which I'm going to play the language is always evolving card, which gives me license to pronounce it however I'd like. Now, pardon me just a moment. Just want to jot down a quick reminder to smack myself later. The scope is an ON SDS 6062, 6062V if that makes a difference. It's 60 megahertz digital storage. They cost about $300 and I recall at the time were the best bang for the buck. I think there was also another one, it was like a Rigol, but it might have had a smaller screen. This replaced a really old 100-pound Tektronix 10 megahertz analog scope. It's also battery powered, which at the time just blew my mind, but maybe they all do that these days. And the current clamp is a Handtech. It's less than $100, I think 70, somewhere in there. It's good to 20 kilohertz and 60 amps. Maybe 65 amps since it's called the CC65. You can set it to either 1 millivolt for 10 milliamps or 1 millivolt for 100 milliamps, so it's not super fine resolution. It feels like it costs less than $70. The button kind of stinks. If you line it up with the text, I think it actually turns off. But, you know, when the light comes on, it seems to do the job. This one has a BNC connector, so it ties right to the scope. And there was my Mitsubishi pencil. You know, when you consider the sheer amount and weight of the words I move around all day, every day, well, let's just say you're not going to be dropping these sick beats with the yellow number 2. Not for long, anyway. Actually, I didn't even realize it was a branded pencil. It's just my white grease pencil. More to the point, some concerns were raised about the wiring of my current limiter, and that it might be suspect in the behavior of the welder. Quite frankly, a small part of me is maybe a little offended. But at 200 pounds, I'm a big man. The potentiometer on the brown and white wires quite simply is connected across the bridge rectifier. I'm kidding. That was a joke. That was a joke. Don't do that. Don't try that at home. That was a joke. It's wired into the header of the cable that comes from the connector on the front panel for the foot pedal. This cable carries 5 wires for the 5-pin foot pedal. So electrically, this potentiometer might as well be down on the floor inside the pedal. It was just more convenient for me to have it up here on the machine instead of having to reach down and adjust something on the ground. An inverter-based welder, I believe, is just a big switching power supply. It's like the power brick for your laptop, but on steroids. And if you're saying to yourself, this old Tony, I know nothing about switching power supplies, well, don't worry. Neither do I. Let's take a moment and just talk big picture, shall we? Mains power comes in the back, which for a hobby machine is usually single phase, but it's not important. That'd be AC, like right from your wall. And for argument's sake, let's call it 100 volts on a 10 amp breaker. The input is a sine wave from the power company. On an older welder, that'd go into a big heavy transformer that'd drop the current in exchange for the voltage. On the output side, say now you have 10 volts and 100 amps. I'm totally making those numbers up, of course. The output would still be AC, and it'd still be a sine wave. That's your classic buzz box stick welder. Throw some sort of rectifier in there, something that flattens out the AC, and you've got yourself a DC welder. Now, this transformation that happens inside the welder results in it getting hot. Usually the manufacturer would add some type of device in there that would keep it from overheating. When the components inside get too hot, it cuts the power to one side of the transformer, and in this case, stopping you from welding until it cools back down. That's what this LED on this machine indicates, over temperature. The amount of time a particular machine can weld for is called its duty cycle. Now that's D-U-T-Y, not the other one. Duty cycle is usually one of the first specs I look at when I'm looking at or someone is asking me about a particular welder. It's a pretty good indication of how well the machine is built. Now, that's not always true, but by and large, a higher duty cycle tends to infer a better build of machine. Now, this particular machine, surprisingly, has a crazy duty cycle of something around 50% at full amps at 40 degrees C. In practice, with 50% duty cycle, with the stuff that I do, I've never run into that. Literally, that light has never come on, though now I'm wondering if it might not be burnt out. Usually, light-duty hobby machines are around 20%. Industrial is likely 100%. Import machines are a little bit all over the map, but they might be down in the 20 to 15% range. I'm not exactly sure. But 15% would mean that in 10 minutes, you could weld for a minute and a half before you'd have to stop and wait 8.5 minutes for the machine. Okay, so now that sounds pretty bad saying it out loud. And it's not that great. But in reality, as a hobbyist, a minute and a half long weld bead is kind of long. Once you've put down a weld bead, you'd likely reposition, maybe do some fit up, bang it around, grab a drink, check in on your friends on Bookface, etc. before you're ready for your next weld. Okay, sorry that got so long. Let's get back to the inverter welder. Mains voltage comes in the back as AC in the power cord and would go into some kind of rectifier and a filter, basically a big fat capacitor bank. That would serve to turn the AC into DC. That DC would then be fed into an inverter stage where it's chopped up crazy fast and changed back to AC. Here, you want to see that again? Chopped up crazy fast. It's just like the inverter you might use for solar panels to get the DC back to AC to run your toaster inefficiently. Or like an inverter that might plug into your car's cigarette lighter. They would turn the 12 volt DC from your car into probably 120 volt AC so you can watch the game on your 4-inch black and white TV in the camper lot while you're drinking your blue ribbon. That inverter stage is why these are called inverter welders, or just inverters. The difference here is that instead of turning it back to 60 hertz or whatever it came in as, it's turning it to crazy high frequencies. Crazy high.
In this welder, I think it might be 40 kilohertz. I could see a 40 kilohertz ripple on the scope in the last video, though maybe it's 20 kilohertz and some kind of rectification showed me 40, I don't know. Anyway, it does that, as I understand it, because it's about to dump into a transformer. This time a much smaller transformers than welders usually needed in the past. I think the higher the operating frequency, the smaller the transformer can be. And that saves a ton of weight, space, and expensive wire. That high frequency AC then would go back into another rectifier of some kind, and probably some sort of inductor to clean it up at that frequency. To get it back to DC you would weld with, the DC we saw on the oscilloscope in the last video. In addition to that, there would probably be some sort of voltage and current monitoring on the output of the welder that feeds back to the inverter to ensure you're getting the constant current or constant voltage depending on the machine, so you can TIG, stick, or MIG weld. So that's what I expect to find in this compacted pile of old VCRs. I might not recognize them, but that's what I think is in there. And one or more of those parts isn't working or isn't working right. Alright, so while I wait for the blood to drain back out of my face, let me tell you what I found so far. Absolutely nothing. Nothing obvious, that is. Nothing that looks like it gave up the ghost. And all told, it doesn't look too dirty, but I'll try to get as much of that dust out as possible. There are 2 or 3 really annoying hardwired connections that are just making going deeper in this thing a lot more difficult. I'll just walk you through the boards as they've sort of come out of this thing. The top smallest board, I don't know what's going on in there, but it looks like sort of the I/O board. It's where the panel and all the other controls attach to. Given the looks, I thought this area was some kind of voltage regulator, but it doesn't appear to be. There's some long through connections that go down to the power board. We'll see that in a second. Immediately below the board was this sort of surface mount. I don't know, looks like logic and stuff to me. There are a few trim pots, but without really knowing what the circuit is doing, I don't know if I could use those to tweak some of the signals I was seeing, the waveforms in the last video. There's the control panel. It's by far the dirtiest part. This was the balance control potentiometer, and I'll test that before I put this back together. So this is the main power conditioning board, I suppose. This is where line voltage comes in. There's a rectifier, smaller than I would have expected, but what do I know? There's the big capacitor bank. There are a couple of relays in here. I assume one of these is for the solenoid, maybe, for the gas. Another one maybe for the fan, but I think this board does some line voltage monitoring. That's what some of this might be. And I know it clicks a few seconds after I turn it on. So I don't know if there's some decision making happening. There's line voltage is good, and so it powers the rest of the machine. On this end, there's also quite a few connections down to a smaller sort of daughter board on the side of the machine. Given its location, I'm going to guess it's probably like high frequency start. So there may be some components up top that also help with that. And if what we looked at earlier were the brains of the operation, this must be the heart of it. While I'm here, I'll take a stab at taking some checks with the multimeter, just diode checks and continuity checks. Anything I can do without power, really. But given the weird problems I was seeing before, I think this thing really probably needs to be tested under power. And, you know, it's starting to get a little bit above my pay grade, above my clearance level. And like I said, shot in the dark, I'll try it again. Okay, so it's finally all back together, I think anyway. I don't have any extra parts. I did have to break this very top end down twice, actually, just because of wire routing. Connectors were sticking out the wrong side, and I couldn't feed them back through. I didn't find a smoking gun in there. I mean, there were some screw connections that were maybe a little loose. Some of these connectors, didn't feel great, but I'd be surprised if they were the problem. I was looking for and didn't really find, test points on the board, unless they're not labeled. Maybe they're just these, big terminals someone could probe at. But if I were to try to test this under power, I really couldn't get to the components that one might suspect could be causing the problems. Anyway, for now, I want to just close this back up and test it again. Maybe take a look at it on the scope. I'm more just curious to see if I put this thing together right than if I actually inadvertently fixed some kind of problem. Well, the good news is it's welding exactly the way it was before. Bad news is it's welding exactly the way it was before. I'm still getting the asymmetric voltage between electrode negative and electrode positive. I'm still getting the weird high base current on the DC pulse, and I still can't get past 50% on the AC balance. But you know, I gave it the old college try. At least the college I went to anyway. Well, that's just great. Now it's starting to mix nickels in with my dimes.